You're good to go.
Oh, we're good now? Everybody in the room can hear me now?
Yes, sir.
All right, cool. All right, let me close the stream so I don't get distracted by the lag. All right, let's get into this. Hi guys, my name's Simon Buckite. My handle is One Nut Wonder, as you see there, and today we're going to be talking about blue team networking. Real quick, let's talk about who I am and why you should listen to me. I consider myself to be a retired black team member. I've been involved with RITSEC since my freshman year. Currently, I am a fourth year BSMS student. I'm graduating in the spring. Super excited about that. I've been involved with our red team as well. I've done some tool development, helped them in some competitions. I've also been a member of the CCDC team for 2 years, both in 2019 and in this past spring in 2020. We went to nationals both years. In 2019, we placed third at nationals, and in 2020, this past year, I believe we placed fifth. I think it was fifth, right in the middle. Super proud of us. We did a great job. In 2019 for CCDC, I was actually in charge of the networking. So that's where a lot of my competition experience in terms of networking comes from, as well a lot of my practical knowledge. And then in 2020, I transitioned over to the Injex role, so more of a managerial role in handling the business tasks and report writing. I've also been heavily involved with ISTS, both as a competitor and then black team for the past 2 years, and probably get roped into doing some black teaming work again this year as well. Also helped out with the CTFs. I'm super interested in web security, web stuff, just application security as a whole, as well as pwn challenges, exploit development, binary stuff. And in my free time, I enjoy paintball on the weekends and video games, because who doesn't like those? Anyway, enough about me. Let's talk about the overview and what we're going to be covering in this wonderful presentation. There's going to be a lot of content, a lot of stuff to go over, so make sure you got your snacks and drink and your seatbelt, because we're gonna get going here real quick. So first, we're just going to talk about some knowledge that I'm going to assume you already know, because we just don't have the time to cover networking 101. We're going to talk about your goals in terms of a blue teamer that is in charge of the networking. We're going to talk about the tools you have available to you and how to use them, the stuff that red team's going to be doing to you, as well as some tactics you can use to kind of combat all those red team tricks. So let's just dive right in. So real quick, your assumed knowledge. I'm assuming that you understand basic networking concepts. So like what a router does, what is routing, switching, basic protocols. You don't need anything too in-depth, but kind of what DNS is and TCP, UDP, stuff like that. Basic networking structure as well. So what does a network actually look like? The devices found, where things are placed, what an edge device is, what a host is, and where all those are. I hope all of us know what a firewall is and what it does. However, if you don't, it will become obvious very, very quickly, as well as understanding the terms ingress and egress traffic. Those are just inbound and outbound traffic respectively, but I just wanted to point those out. Cool. So competition overview. For those of you who haven't competed, you'll generally be given a topology that might look something like this, either a week or a few days before, or even the day of. In the case of National CCDC, you get handed the topo like a few hours beforehand, which kind of sucks. But here we have our wonderful Angry React, which represents the red team. That's where all the red team traffic is going to be coming from, as well as scoring and any white team networks. So that's basically the internet as far as your team is concerned, and where all of the scoring is happening, and malicious things. The blue arrows are pointing to edge devices. So these are going to be your gateways for all of your hosts. Typically, these are just routers with some firewall capability. Most commonly, it'll be PFsense or something similar. And then you look farther into the network and you see you might have other networking devices like a switch. Sometimes in really large competitions, you'll have another network which will have its own edge device, and that gets super complicated really fast. But then you'll have your hosts, and you can be like the poor unfortunate blue team down here in the bottom right, and you get stuck with a printer. Thank God I've never had to defend one of those networking wise before, because I'm sure it's awful. Anyway, keep this picture in mind if you want to screenshot it real quick, or just ingrain it in your brain, and think about this as we talk about the concepts of defense and blue teaming your network, because it'll help to think of it in a broad picture this way. Let's talk about the goals that you're going to have to meet as the networking person for your team. So first and foremost, you want to stop red team traffic, right? That is your basically number one goal, right? You want to stop the bad traffic. So the red team traffic is going to look like your beacons, just SSH connections, any netcat, really anything malicious. You want to stop in some way, shape, or form using your network abilities. But that also comes with the challenge of allowing scored traffic at the same time. So what happens if, red team's using HTTP to communicate and you have an HTTP check on that box? You have to figure out how to stop the bad traffic while still allowing the score check to go through and pass. Um, so you'll get a lot of your team yelling at you and saying, "Hey, this service is still down. It's definitely your fault. You wrote a firewall rule. Fix it." And you'll be like, "Nah, man, that's all you. Haven't touched anything." That happens a lot. Another thing that happens a lot is you having to deal with allowing benign traffic as well. So again, it's very common for people to say that a competition is supposed to simulate a business environment. It's supposed to simulate what a IT security team is going to do. For those of us that have competed, we know most competitions that's kind of a yikes, because in competitions you generally just firewall off basically all the traffic and just allow scored stuff, which would never fly in a business. If you decide to pursue CCDC and compete in CCDC, they have a lot more business focus and are a lot better at that. They have a lot more requirements of things you can and cannot block. But with allowing benign traffic, such as your team members who need to download packages, search Stack Overflow, and fix other problems to do injects, they're going to get really upset with you if you just slash all network connectivity, and you're going to get yelled at a lot. So it's just going to be like, "Hey," and then insert your name here, and then "Can I have internet?" will be said to you at least 30, 40 times per competition. And just expect that, be ready, and just come in with a mindset of being patient with your team, and that will help a lot. But these are your goals, so just keep those in mind as well. Let's talk about the tools that you have in your toolbox. So obviously, you're going to have firewalls. Those are going to be your bread and butter for everything. The really important thing to note here is that both your networking person, so what this presentation is kind of focused towards, your networking person for your team, as well as all other members of your team, need to be doing firewalls. Okay, and we'll touch on this multiple times here, but there's this concept of having macro and micro rules. Okay, macro, very big picture. Think about that gateway that where those blue arrows were pointing in the topology. Those rules are going to kind of apply to your broad network as a whole, and micro is going to be more host based. So if your host only needs web connectivity like HTTP in, you only really need to allow HTTP in, or maybe ping. Like you only need those two protocols. So you can kind of get a little more strict on the micro basis, but then macro, you have to kind of open everything up. Also, this is not a comprehensive list of all of the technologies and things you have available to you. But some of the firewall technologies you should be familiar with are IP tables and the Windows Firewall, NetSH, Advanced Firewall. No idea if that's the one you're supposed to use because I'm not a Windows person, but I'm pretty sure it is for the newer versions. You also have the actual dedicated devices, which are generally your routers. They provide routing functionality as well as packet filtering. And these are going to be things like PFsense, Palo Altos, and then a new one that I actually ran into last year at CCDC, and that was ViOS. So PFSense and ViOS are actually based on Linux distributions. Sorry, PFSense isn't based on a Linux distribution. It's based on BSD. I said that for convenience's sake. Don't get upset. But PFSense is based on a free BSD platform, whereas ViOS is based on Debian. So if you run into those two technologies, you need to keep in mind that you still have that underlying operating system to defend as well. If you get a Palo Alto, those are a little different. Those are commercial grade devices. You can either get a physical one, which are super, super cool, or a VM, which is doubly cool. These are a little less common. I believe we had these at ISTS last year. Not sure if we're going to try and have them again. I'm sure we'll try to have them again. But these are really common in CCDC as they're a big sponsor. And obviously, since they're commercial, they'll come with their own sets of challenges, but they'll be drastically different from PFSense and ViOS. But But the great thing about PFsense is it's super easy to use and set up. And we'll talk about that a little bit later in this presentation. The next thing that you have as a tool is Insight. Now, most people, whenever they blue team, they'll go through their system, remove services, and if nothing happens to their box and their service stays up, they're like, woo, we kicked out red team. Good job, team. And then like 10 minutes later, things get nuked and they lost their box. Like they're playing Flappy Bird nuked. So basically, they're taking on the principle of it only exists if they can see it, which is obviously not the right idea to have in security, and that can really burn you. So it's really important to get some insight into what's going on in your network. And we have some good tools to do that. Wireshark is the pretty de facto go-to for seeing what's going on in your network in terms of packets and traffic. However, you do need a GUI to use this on both Linux and Windows. So there is that limitation because most of the time, whenever you're given a Linux system, you're just going to be given the terminal. Most of the time, you're just given like a server distribution or a server ISO install, and that's not going to have a GUI by default. Yes, you can install one, but then that takes time out of your 5-minute plan and yada, yada, yada. So a really powerful tool you can use is tcpdump. We'll talk about that in another few slides a little more in detail, but it's a super powerful tool on the command line that doesn't require a GUI. And of course, you obviously have the other network inspection tools such as SockStat, NetStat, LSOF, and all the other ones. I know those three in particular were covered in the Blue Linux talk. So if you need a refresher on those, make sure to go check that out. And finally, in networking as a blue teamer, you just have what you know. This is super, super powerful. You probably heard a lot, knowledge is power, but networking especially is really freaking complicated. I still mess it up all the time. I reverse things, flip things around, especially whenever it comes to things like NAT. Oh, NAT. But yeah, it's super confusing. Don't worry about it. You'll get it eventually. Just keep plugging away at it. And honestly, just the more you know about how networks work and the protocols involved in them, the better you will become as a blue teamer. So this is just an overview of the tools. Let's dive into firewalls a little bit more. First thing with firewalls is we want to talk about the logic of a firewall, okay? So you may have run into this before where you're asked about the order of rules, okay? So there is, in fact, a difference between Linux and Windows, unfortunately, and it's very strange. So for Linux, de facto, IP tables, cool. Pretty straightforward as you put rules into chains, such as the input chain, and a packet comes in, it's picked up by the NIC off the wire, and then the kernel starts filtering it. What's going to happen is that packet is going to be put through your rules one at a time. It's going to start from the top, and it's going to work its way down. It's going to check the first one. Does it match the first rule? If no, continue. Does it match this one? If no, continue, and so on and so forth until it either matches a rule, and then that rule is applied to the packet to either allow it or drop it. Or if it matches no rules, it's going to hit that default policy. And here in the screenshot, you can see policy accept next to each of these chains. So that's showing the default policy that's currently enabled. As you can see, I have firewall rules on my personal laptop. I hope you see what I did there. It's really weird not being able to see or hear anybody laugh. So I'll just imagine. Anyway, moving on. Windows firewall is very strange. Whenever you add rules to the Windows firewall, it doesn't do it in the order that you add them. The Windows firewall will actually evaluate a block rule first, then a match rule, and then the default rules it has. Okay, so if you're adding in rules like, okay, I want to allow, HTTP to like this box or like this protocol, blah, 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 blah. And then you add like your block all at the bottom of the Windows firewall, thinking it's going to evaluate in order. It's going to nuke you. Windows is going to say, oh, I'm going to block traffic first, which is kind of nice, but it does make it confusing if you're transitioning from Linux. And obviously those matching rules are a lot more nuanced than that. And you can look up, I think on MSDN, they have stuff on that. But that's just something to keep in mind, that the order does matter for some things, and then for other things it doesn't. Now, circling back to the default policy thing, specifically on Linux, I will make the argument till I die that your default policy is better to be accept rather than deny. And here's why. Imagine you are blue teaming a cloud box. So you are using a client that you have console access to, and then you SSH into your cloud box to administer it, lock it down, do your 5 minute plan. And then red team comes along as they do, and they flush all your firewall rules. Well, if your default policy is drop and you had rules allowing SSH so you could administer that box, those rules get dropped. Your SSH session will hang. And now that the default policy is dropped, or the default policy is deny or drop, you can no longer access that box again. That box is now dead. There are no rules allowing any more traffic. Everything's just going to be dropped. The only way for you to get that box back is one, if white team's really nice and you can buy things from a shop, or two, if red team's really nice and you can bribe them or make a deal with them. Don't recommend it usually because it's usually heavily detrimental to your team, but that is an option. If your default policy is accept, on the other hand, and red team comes along and flushes all of your rules, you'll still be able to SSH back in, right? Because now your rules may be gone, but your default policy is still accepting your SSH connection, so you can still get back in. Now with hosts, whenever you're writing host firewall rules, that gets a little different because if you have console access the whole time, you could make the argument that you could do the default policy as drop. However, in my opinion, it is better to have your default policy uniform across your network. So that way, if you have to swap boxes in the competition, which will happen, or everybody's on the same page on your team, everybody knows what the policy should be, and you don't have any mix-ups or screw-ups, because that can really come back and hurt you later in a competition whenever red team turns up the heat. And then, as with firewalls, they work usually at layer 3 and 4. In terms of blocking IPs, and then you can get protocols in there as well. The Windows firewall will allow you to block applications, which is super awesome. You can only allow like Google Chrome out. And then basically if you try to use Internet Explorer, I don't know why you would, but if you did, that would be denied by the Windows firewall, which is super powerful in a competition, especially at the ones that we host and University of Buffalo hosts. If you do pursue CCDC, be careful with this one because we did have an issue in the past where they caught on to us using Chrome, and I believe they injected into our Chrome process in order to continue sending their beacons. That's a more advanced topic. Don't worry about it for these competitions. Just something to look into and keep in the back of your mind. The other important thing with firewall rules logic, alongside the default policy, is instead of having the drop there, you want to have a drop rule. Sorry, I'm circling back a little bit. I missed this part. But so you want your default policy to be accept, and instead at the bottom of your chain, in the case of IP tables, add a block all rule. So have some type of rule that just denies all traffic. So you have your default policy, which is if no rule is matched, and then you have your firewall rules allowing all your traffic. And then at the very bottom, the last rule that'll be evaluated will be a block all. That way, if everything gets flushed, you still have access. But if the rules stay in place, red team has a much harder time. So let's talk about that macro and micro a little bit more. Again, macro is that big idea, the big picture of your network. So this is going to be more at your gateway. So your PFsense, your Palo Alto, Vios, whatever device that you have there. You're going to need both ingress and egress rules on your edge devices, as well as that block all rule that I just talked about. You'll have to check for specifics, but most firewalls like PFsense and I know Palo Alto in particular follow the same ordering of rule blockages. PFSense is a little different, I think, because I've been bitten by that. It might go like bottom up or something like that. It's a little weird, but it still has some sort of ordering in terms of how it evaluates the rules. And again, micro is going to be your host based. So every host must have firewalls. I'm going to say that again. Every host needs to have firewall rules, both ingress and egress. Okay. A lot of teams will just put firewalls on their network, like on their network device, on their PFSense, on their Palo Alto, and they will neglect their host-based firewall rules. Why is this an issue? Well, me, Simon, malicious red teamer that I am, will have control of at least one of your boxes the duration of the competition. We start losing your other boxes because your networking guy is doing a good job. I'm like, let's see if I can really start causing havoc inside their network to take them away from the router and direct their focus somewhere else. If your hosts don't have firewall rules, I can just freely pivot inside your network. Pivoting is something that a lot of teams don't think about and don't think that we do, because most of the time we just have control of your boxes. But if we start getting in a tight position, and by we, I mean red team, if we start getting in a tight position, we'll start pivoting through your network. If we control one machine, we'll pivot just SSH inside your local network, because most of the time we still have your passwords. But if you have good firewall rules on every host, that becomes much, much more difficult, and we get a lot more frustrated. And then we spend more time on your team trying to figure stuff out, and that helps other teams. But you may not want that. But most of the time we get frustrated, and then we end up getting kicked out sometimes because you guys have good firewalls. So don't underestimate the host rules, as well as the macro rules on your edge devices. Super important. So let's talk about PFsense now, a little more specificity in terms of firewalls now. So as I mentioned before, PFsense is based on FreeBSD. It is a PHP web application that provides a nice interface for you, and you can see a picture of it there in the bottom right, to administer your firewall, write your rules, monitor everything, and do all that. Again, I need everyone to repeat after me. This is super important as well. PFsense is the web interface. PF is the firewall. Okay? Whenever a new blue teamer gets PFsense, they just go straight to the web interface, only use that. They might use the CLI interface there that's showing. PFsense will give you those options there, and you can type in like 5 to reboot the system, shenanigans like that. But they will neglect the fact that they are just using a PHP web application running on FreeBSD. Okay. So that means you still have an operating system, you still have a BSD distribution to defend as a blue teamer. You're not just doing networking on this box. You still need to audit it for users. You need to audit it for services. You need to audit the PHP web application. For those of you who know web stuff, PHP is disgusting and broken. It is super, super easy to write a web shell, plop that into the PHP directory where the application is being hosted, and then red team basically has infinite access as long as they can hit that web interface. Those are all things you need to keep in mind. But PFsense is really awesome because it's super user friendly, and all those other things. But usually the trade-off is whenever it becomes more user friendly and things are abstracted, that's just way more attack surface that you as a blue teamer have to deal with. So pro tip, pro strat is learn the PF CLI. It's not like IP tables because it's a completely different thing, but you can write rules in PF. It's a similar thing. You'd have to look it up. I don't remember the syntax because it's confusing to me. But you can just turn the web interface off, turn it off, and then just write your rules using just PF. You can do that. And that's actually a good strategy that a team has used against. I know I've run into it one time at University of Buffalo blue team last year. Their router guy did that, and it was really annoying. So yeah, just keep that in mind. Like this thing runs Nginx, so all the blue team hardening still applies, auditing Nginx configs and all that stuff. So just keep that in mind if you do get PFsense. So after a long talk about firewalls, let's talk about the next thing that you can do to improve your networking defense, and that's Insight, specifically with tcpdump, because most of us have experience with Wireshark, and if you don't, you have labs, lots of labs that deal with it from the networking classes and CSEC classes. So tcpdump, just super simple CLI tool for NIC systems, Wireshark-esque. The screenshot is literally just me doing sudo tcpdump with no flags, no filtering, no nothing, and then control seeing it as fast as possible so I didn't just get like slammed with packets. Would have been really bad. tcpdump is super, super powerful. I've used it a lot whenever I'm debugging networking programs on my laptop because I'm just lazy sometimes with Wireshark and it's annoying. Super useful from a blue teaming standpoint because you don't want to take the time to install that GUI and wait for Wireshark to download and all those other things. TCPdump usually just comes with most distributions, so it's already there. So if you can learn how to use this, it's super powerful. Also, here's another pro tip. Whenever you're viewing traffic, whether it be in Wireshark, tcpdump, I think it's TCP view for the sysinternals tools, any of that stuff, in a competition setting, most outbound traffic will be red team traffic. Because if you think about it, in a competition, all of your team, all of your blue team, you guys are going to be mostly like hunkered down, typing away on your host that you're worried about, doing your firewall rules, service auditing, all that stuff. You're not really making that much traffic. You might go download the occasional package, but you're really not doing that much in terms of network traffic. So if you whip open TCP dump and you see a ton of stuff just flying out of your box going outbound, it's probably red team, which means they're probably still in. So this is just a great way too to get some inspection into your network, some insight. So that way you can still see like, hey, are we, getting bodied? And then what you can do is you can correlate these results from the host and then to your edge device. So what you can do is you can have one person, say on your Ubuntu web server, whip open TCP dump, see what's coming out of his box outbound. And then you can have the guy on the edge device, say PFsense. You two can talk to each other and then match up like, okay, hey, I'm seeing this traffic going to this IP. Is it being blocked at the router? And then your router guy can be like, oh, yeah, I see it. It's being blocked by this rule. And then cool. So now, even though there's still stuff on your host that's trying to communicate, it's being stopped by your router as far as you can see past that point. So again, being able to see what's in your network going on, super powerful. Can't understate it. All right. Knowledge. Got my Lamborghini. No, I wish. But this is what you come to club for. Networking is really difficult. You do have two wonderful classes that you'll take as a CSEC major. I can't speak for any other majors because I have no idea what your programs look like. But I believe in your second year as a CSEC student, generally you will take a networking services class. And then I believe in your first year, you'll take routing and switching. Network services is a super awesome class. Please, if you pay attention to one networking class, pay attention to that one. That one does a deep dive into a lot of the protocols like DNS and DHCP, which are like integral to any network that you'll run into, whether it's in competitions or in industry. If you haven't yet, you'll hear a saying of it's always DNS. And that's because if DNS goes down in a competition, you usually lose like 4 or 5 other checks just because DNS went down. And that just has to do with the way the protocol is and how everything is like based on DNS. If you lose that, that's a huge hit to your network and especially your company if your DNS goes down in your company. So super awesome classes. Pay attention in both of them. But at the end of the day, having an effective network defense requires you to understand all the nuances of the protocols and how they interact with each other in a network and what's going to happen if this host disconnects and then reconnects. Like, how does all of that interact? How does DNS work alongside DHCP with the leasing, all of that stuff? You also need to know all about the networking devices that you're given. So if you're given ViOS, and you've never used it before, chances are you're going to struggle a little bit getting up and running. The concepts are going to be the same in terms of how you apply the firewall rules, why you apply them, and what your goal is, but the syntax is going to be completely different, as well as the way you interact with the device. Okay, so that's just part of the game as well, as being prepared for anything that you're thrown during the competition. Now, hopefully you'll again get the information beforehand, so that way you can, kind of prepare in the weeks leading up to the competition. But if you're not given anything till day of, you best be prepared for it. And then finally, just you need to have an intimate understanding of your team's network. And that goes along with, if you get the topology, start planning, like maybe set up a test network where you can start practicing writing rules and stuff. Just get an idea of what's going on in the network. And then competition day, expect changes. maybe sit down and after you run through your 5-minute plan, whip out Nmap and just Nmap your entire subnet and then go through your lists of hosts and be like, okay, is everything here? Is there anything new? Is there anything weird? I know, I think it was 2019 CCDC, so not this spring, but last spring at regionals. um, I was in charge of networking and I kind of neglected this one, but it was a little weird. Red team actually had a box on our network, on our layer 2, that they would pivot from. Because what happened was at the end of day 2, we were pretty locked down. We were pretty solid, feeling pretty good in terms of like networking and traffic and stuff. But we still had services going down. And we were like, what the heck is going on? Like I saw no traffic going through my Palo Alto. So it made no sense why we were losing things, but that's because they were pivoting into our layer 2 and they were actually ARP poisoning us, um, that's a whole other thing. That's out of the scope of this talk here. But that's something to look into is ARP poisoning. Doesn't happen that often. Only happened to me once. Didn't work all that well. It was just really weird and annoying to try and debug, but just something to keep in mind. Just you need to know your stuff, which is true for any blue teaming position, but networking especially. So we've covered your goals. We've covered what you can do to meet those goals, but let's talk about now what the red team can do to stop you and what the red team kind of does in terms of networking things. So as I mentioned previously, the red team's primary way of communicating and controlling your box is going to be with beacons. So essentially there's an implant, the malicious malware on your machine. That's going to periodically call back to their command and control server. And then if they want to, their server will respond with a command like rmrf slash no preserve root. And you just say goodbye to your box after that. But that's the way the beacons work. And I'd say roughly competitions as a whole, about 90% of beacons are going to leverage DNS and HTTP as their protocol for communication. Okay. If not more. That's the most common one because they're super easy. Now, the problem with that is, and if you've competed, you know this, DNS and HTTP are heavily scored services. It is very common to go to a competition and see 5 or 6 HTTP checks, okay, across your network. So that means you have to somehow stop the bad HTTP traffic and allow the scored HTTP traffic. This is where the crux of the problem is and what you have to solve as the networking person for blue team. Same with DNS, very important service, always scored, maybe not as many, but it's still scored. You might have 1 or 2 DNS checks instead of, the 5 or 6 for HTTP. The next little spicy trick that red team can do is they use raw sockets. Now, I actually gave an entire research presentation on this topic last year, and you can find it on the RITSEC YouTube page just by searching for raw sockets or my name. There's the link for whenever these slides will be posted later. But it's a 30-minute talk, super in depth on what they are, how they work, why you use them, and how to stop them even. So I highly recommend you watch that. But for this talk, essentially all you need to know is raw sockets allow you to bypass your host-based rules. Now, some of you may be like, well, Simon, didn't you just say that hosts should have firewalls? What's the point of having them? Well, yeah, every host should have firewalls, but the amount of raw sockets being used is generally not that high because of the developmental costs and the things I talk about in that research presentation I gave. But the host-based firewalls, again, will stop the pivoting. The raw sockets are generally not used for pivoting. They are just used for general command and control from your box to the C2. Okay, so if you start thinking, why do you need host rules? Just remember the pivoting, and it's just another layer that red team has to deal with. And then the final thing that red team is going to throw at you is going to be router malware. Okay, think back to that topology I gave you at the very beginning where the blue arrows were pointing. That is a single point of failure, okay, because it is one way in, one way into your network, and one way out. Red team hates that whenever that's in a competition. Why? Because if you lock down that one point good enough, you win. Red team can't touch you. You're done. Like if you allow scoring and kick and block all red team from that one point, that's game over. Like that's your goal, is stop red team traffic. So red team, you can guarantee they're going to do everything they can to try and keep you from doing that. So they are going to throw router malware at you. As I mentioned in the PFSense slide, you still have that FreeBSD operating system underneath. So you still need to blue team your box. Okay. And this goes for any router, anything, Palo Alto, Vios, anything you get as your router, you need to blue team. Okay. So you need to audit your users and everything like that. Those principles still apply. So just keep all of these things in mind. And these are some of the tricks that red team are going to use to try to get you guys. So what are some things you can do to combat these things that red team are doing? The first super powerful thing is leveraging statefulness. Now, statefulness is just a way that a firewall, most firewalls work, and they actually keep track of the session whenever it's created. So if you have a TCP session that is initiated, the firewall will actually track that session and allow that traffic to go back and forth without re-inspecting all of the rules and reapplying all of the rules, because it knows there's already a connection that it allowed in the first place. So it's like, you're good, I'll let you through, keep going. So this is super useful because you can, on your edge device, allow HTTP in, let's say, for scoring, but then don't have an egress rule for HTTP out. And what'll happen is the scoring request will come in, hit your web server will respond, and because the request that was already allowed in, the router will allow that response back out. So scoring will continue to work. However, let's say red team has an HTTP bot on that same box. Whenever that bot tries to use HTTP out, because there is no rule on that router or on that whatever device you have there that lets HTTP out, it'll be dropped, it'll be killed. So you're scoring and not allowing red team out. So that's first thing, leverage. Think about that whenever you're writing your rules. Second, choke points. Again, look back at the topology at the very, very beginning. One way in, one way out. The more of those choke points you can create in your network, especially for different protocols, the better you will do in terms of stopping red team traffic. Because this makes your application firewall rules much, much more efficient if you only have to write them once and get them to apply to all traffic going through them. Okay, so that's something else to keep in mind. And the other thing is proxies. Proxies are super, super powerful and are protocol specific, and they'll allow you to do logging, so that it gives you even more insight into what's happening in your network. And also what happens if you use a proxy. Let's take HTTP as an example. Say we set up an HTTP proxy. We point all the hosts in our network at said proxy, and then this proxy makes outbound requests for us. What's going to happen is at your edge router, your edge firewall, you can set a HTTP rule that only allows HTTP outbound to the proxy, to and from the proxy. So that is the only thing allowed on web out now, HTTP out. That is going to just completely cut red team in terms of their HTTP traffic, because now no HTTP traffic is allowed out from hosts unless it goes through the proxy. And then you can also log everything there as well. You can also do this with DNS, and you do DNS forwarding. It's a little more complicated, especially getting Windows and Linux working, but you can do it, and it is a super, super powerful strategy. One other thing that you need to do, again, you are still a blue teamer. You still need a 5-minute plan. So come prepared with your rules stubbed out, especially if you're given the topology beforehand and you know the services and things to expect. At the very least, come in with everything stubbed out, what you're going to do and how you're going to do it. This is going to save you a ton of time in terms of syntax, typing, and thinking. You can actually focus on what needs to be done rather than being like, oh crap, is this a capital A, lowercase a? Like, what's the syntax here? So make sure you come prepared. And again, I can't stress this one enough either. Treat your networking device as a host. Still, you have to change user passwords. Even on a Palo Alto box, you still have to audit your users, your admin users, and change the passwords. Audit the services that are running. On PFSense, you can have SSH open. It runs Nginx to serve the PHP web app. So like you have all of these services still that you have to watch and monitor. You have to lock those down the same way you would for any other machine. And finally, just check for general backdoors, look at processes, look at services, just general blue teaming still applies for all of these devices. That is overlooked, I'd say, by 98% of new blue teams. They forget that their router is still an operating system. It is still something that red team will have control over. It is not just a point and click adventure through the GUI and you write rules. All right. Just remember that and you'll be golden. And finally, just some parting advice for you guys from me, who's leaving soon. I'm tired and old, and yeah, I don't know. I hope everybody's still watching. But anyway, go slow. Okay. Whenever the competition starts, your adrenaline's going to be going, your fingies are going to be shaking, your knees weak, your arms will probably be heavy, and you left your mom's spaghetti out in the car and you'll be super sad. Just go slow. Don't make too many typos and just focus on what you're doing. Remember, as you write your rules, and this applies for both your networking person and all the blue teamers on your team who are also writing your host rules. Don't forget the host rules. Write those one host at a time. And as those happen, as you apply those rules, watch the scoreboard. And if a check passes after you've applied the rules and you're still green, cool, move on to the next one. But if it goes red, it might be the firewall rule you just applied. So you do this one host at a time, so that way you don't red board yourself right out the gate. Okay. So just go slow, be methodical, and think about what you're doing. Also, be patient. Your team is going to yell at you and blame you for everything. Oh, it's awful. It's really rough. Anyone who's done networking knows exactly what I'm talking about. Just be patient with your team because they're under a lot of stress as well. Talk through the problem with them, troubleshoot any networking problem how you normally do. Try to ping, check DNS, check all these things, and you'll troubleshoot everything under the sun, and then it still ends up being DNS. That's usually how it goes. But just be patient with your team. And finally, I know, yet another cliche, but communication really is key. All successful blue teams have great communication. That's the only way you can be good. It's the only way that you will come out on top in these competitions is if you communicate with your team and make sure everyone's on the same page, especially with networking, because if you're writing firewall rules to cut people off from the internet, you need to tell them so they don't get upset. And then they come back and yell at you, and this process just repeats. Okay, so just communicate with everybody and it'll all be good to go. And with that, I hope everybody got something out of it. Let me quickly pull up the stream again here. And we can go through some questions if people have them. All right, I now have the stream up. I am now watching chat if you would like to ask questions. What are the chances that a red team or RMFing your box when you accidentally clear your firewall? So generally what'll happen is with the competitions like that we host, specifically IRSec and then UB, I know specifically do this, there will be about an hour to 30 minutes when red team is hands off at the end of the competition, and they'll come out and help you, and that'll be your time to do IR. So generally there will be a small time frame where red team will no longer be attacking you for you to do your IR. Now, this is obviously not going to be the case whenever you do CCDC and more competitive competitions like that, but there is a time frame allowed for that. How do you write better IP tables rules? Take the principles that I just described in terms of the macro rules. So, limiting just scored traffic in, only allowing what you need to, and then apply those to your host rules with the IP tables as well. I'm sorry, I didn't get the CDT reference, Darkfowl. But yeah, so you just want to take all those principles and then apply them to a much smaller scale in terms of your host. One module to look into for IP tables is actually I think it's a state module. So you can actually do state with IP tables as well, where you allow established connections, new, I don't remember all of them. But honestly, you just have to play around with IP tables. As with anything in this industry, you just have to practice. I know it sucks and it's hard, but you just got to spin up a VM and play around with it. But yeah, that's it. Any other questions, guys? Any in the room? in the chat. We got 30 viewers. How do you learn how to use big, expensive systems like Palo Alto? Yeah, so that is kind of a problem. So I'm not sure how we handle this for ISTS in terms of the blue teams learning. I know for CCDC, they give us VMs. So like whenever I did CCDC, Palo Alto distributes they're called VM100s. It's one of their versions of their device to all the teams to practice with. So that way we can actually be prepared. It is much more difficult if you are just a normal blue teamer doing these smaller competitions. The Palo Alto documentations are hot garbage. They're really awful, really hard to use. The interface as a whole, though, is pretty straightforward. So if you run into a competition where you have one, probably just ask white team or a black team member and be like, I've never used this. Can you like give me a 5-minute rundown on how to use this thing? And hopefully they'll help you. All right. How do we write rules to block specific types of traffic on a port, like how you were discussing HTTP and DNS, where both blue and red team is using it? If we can't, what should we do? Okay, so I'm going to use IP tables here as an example, more host-based approach here. So whenever you write an IP tables rule, you can specify the protocol. I believe it is a lowercase -p. You might have to check the man page on that one, but that's what I'm going to go with. And then you would just specify the protocol, so like HTTP, and then obviously allow or deny. Now, the issue lies in the other part of your question. What if red team is using that protocol as well? So there's actually not a lot you can do in terms of just the IP tables rule, because you can't do any DPI, which is deep packet inspection, which is actually looking at the content of it. It's a lot harder to block that, but you combat that by using the proxies, by the different networking strategies. And also you do this at the edge device. So like I said, you would allow HTTP in for scoring, but don't allow it out, because remember the statefulness will still be there. So whenever that bot beacons out with HTTP, even though your host firewalls allow it, hopefully that edge will still be blocking it if the rules are set up properly. So that is my advice for that. Doesn't Palo Alto have DPI? Yes, it does. Can't say I've ever gotten it to work though, even at CCDC. Hurrah. Yeah. Yeah, firewalls, guys, you can't underestimate them. You get a good networking guy on your team, and you guys can just like you just crush them. Yeah. Yep. Okay, so you can message myself, Simon Buckite on Workplace, One Nut Wonder on Discord. For whatever reason, I'm an alumni in Discord. Not too sure why I'm an alumni, but I am still a student. I graduate in the spring. You can message me on either platform with any questions. Would we use the proxy as a filter then? Question from Elijah Troy 90. Sorry, I'm terrible with names. So the proxy wouldn't so much be a filter. Think of the proxy as like it's a bottleneck, right? It's a choke point. So then at the edge device, you only allow the proxy traffic out, and then any host requests that you make would be made through the proxy. And chances are, like personally, whenever I write malware, I don't think about a proxy because that's complicated as shit to try to program into your tool. So what you do is you literally just be like, all right, here's my bot, here's my server. They're just going to talk directly. If you put a proxy in here and then you block the traffic properly, my bot's still trying to go directly to my server, but is not allowed because the only place that's allowed out now is the proxy. So that's what proxies are used for, as alongside with logging. And the other person you can message who was phenomenal with networking, he did networking last year for CCDC, is Adriano. I believe he's in the Discord. I don't know if he checks Workplace too much, but if you message him or you message me, I can get you in touch with him as well. He was a legend. He did super, super well with CCDC. So that's all I got for you guys, unless you got more questions. So by redirecting the traffic through a proxy, we can foil tools which are expecting us to go straight through the router or something. Yep, that's exactly it. All the proxy does is redirect traffic, allow you to lock things down more. And then since you are redirecting your traffic, red team tools are not expecting that, so they won't work anymore. That's exactly right. Yeah. Cool beans. I think we're good. I'm not sure what I do now though, in terms of like this Zoom format shenanigans.